Hello and welcome to Okube, an organization building open source solutions for data intelligence. Today, we're diving into what Laktory, the dataframe-centric open source ETL framework, is all about. We'll show you how to effortlessly craft a data pipeline, run it locally using pollers for quick testing, and then take it to the next level by deploying and executing it at scale with Databricks Delta Lives tables and Spark. But before we do, if you want to ramp up your data and AI engineering game, make sure to like and subscribe. At its core, Laktory pipeline model is a collection of interconnected nodes. Each node generates a data frame by reading a source, applying transformations through a transformer, and optionally writing the output to a sink. As any Laktory model, a pipeline is entirely serializable and generally declared from a YAML file. Let's explore how you can declare a pipeline that reads stock prices from a JSON file and create multiple pollers data frames following the medallion architecture. First, we declare a node or data frame for the bronze layer, reading the data using a sink and creating a Parquet output. Next, we write a Python script that reads the pipeline YAML file and execute the pipeline, generating a data frame that we can examine. The logs describe exactly how the data was read and what kind of transformations were applied. The result is a data frame with the same structure as the raw JSON files. Next, we introduce a second node in the silver layer. Notice how the source is the previously declared bronze node. This sets the dependencies between nodes. Then, we list the columns using pollers or SQL expressions. We are now ready to rerun the pipeline and explore the silver data frame. As expected, columns are now properly defined. We complete our pipeline by adding more nodes, including a join and some analytics-ready aggregated data. Each transformation is defined with a standard pollers data frame function and its arguments. Notice how the join can reference another node. You will also find familiar pollers expressions for columns definition. Executing the pipeline again gives us the daily aggregation we were looking for. We now have 1 row per day per stock. This is all great, but what if we have massive amount of data? How do we scale this up? This is where Laktory really starts to shine. With a few tweaks to the configuration file, you can switch to Spark as the data frame library. We will also modify the data sources and sinks to point to volumes on Databricks. The few pollers expressions need to be updated to their Spark equivalent. We update the execution script by passing a Spark session, created with Databricks Connect, to the execute method. The pipeline will now effectively run on a Databricks cluster using Spark. As with pollers, the resulting data frames can be examined from the terminal. Heading over to Databricks shows that all the Delta tables were created as expected. This is great, but triggering a pipeline run from your local machine is not something you want to do in a production environment. Laktory has been built from the ground up to define and deploy resources. For the pipeline, we can set a Databricks job as the orchestrator. Then, we include the pipeline as part of a stack, which is a collection of resources to deploy, including notebooks, catalogs, workflows, and associated permissions. The Laktory CLI can be used to deploy these resources. Terraform or Pulumi backends are used for the deployment. Adding a pipeline to the stack will deploy a pipeline configuration file, a Databricks job, and all the associated tasks. Heading over to Databricks, we can see that each task is a single pipeline node execution. Task dependencies is also automatically set. This allows workload parallelization. Running the job will write the exact same Delta tables as we had locally. And voila, our pipeline run is complete. Running a Laktory pipeline as a Databricks job is great, but using Delta Lives tables enables advanced features such as automatic schema management, fault tolerance, and backfilling. In this configuration, we also change the sinks to be Unity catalog tables. Once the config is updated, We rerun deployment to create the DLT resources in Databricks. Before jumping back to Databricks, let's look at a Laktory feature that embraces DevOps best practices. The CLI run command can trigger workflows directly from the command line. In Databricks, the DLT pipeline has not only been created, but is also running because of the CLI command. The logs, statuses, and failures are reported back to the command prompt, and the execution is completed. Looking up our catalog, we can find and explore the newly created tables, including the data lineage that has been automatically generated by UC. Once we are satisfied with our pipeline configuration, we can leverage the Stack multi-environment support to deploy to production. This concludes our Laktory overview. Configuring, testing, deploying, and running a data pipeline has never been easier. With support for multiple dataframe libraries and built-in infrastructure as code capabilities, Laktory offers a consistent, data-ops-friendly interface that simplifies data transformations at any scale. From a straightforward local polars implementation to a feature-rich Databricks Delta Lives tables deployment, Laktory has got you covered. You also get the superpower of prototyping, running and debugging a DLT from your favorite IDE. We hope you found this demo helpful. Are you excited to start using Laktory? What features would you love to see in our future releases? Drop your thoughts in the comments below. See you next time.